Hello everyone. So today I'm gonna show you guys my approach about fixing my own mechanical keyboard. So right here in front of you is a Keychron K6. That was my very first mechanical keyboard, and back then I didn't know a single thing about mechanical keyboard. So after a few reviews I saw on the YouTube and internet, I just went with the Gateron Blue switches. And it's also the soldered version. Because I was naive, I thought that this will be my only mechanical keyboard and I would love the clicky feel. As I know more about mechanical keyboard, I started to go with hot swappable and linear switches. And ever since, this one has been left dusted in my drawer. So one day I was thinking, it may be convenient if I install the socket, so I can turn this solder board into some hot swappable board. And there I make the huge mistake, where I did not research enough. And I choose one of the socket that has some wrong dimension. And I was trying to hammer that in. And that, as you may already know, it broke my PCB. And what's even worse, I snapped at it. And together with my terrible soldering skill, I managed to turn this poor K6 into decorative LED light. And because I even break the lighting key, I can't even switch LED mode. That made me regret myself so badly. Therefore, I researched heavily onto how I can revive this keyboard. By the way, this is the socket that I hammer in and break my entire PCB. So if you do consider buying a socket, go with the smooth stem one. And this one has some bump on the surface. Don't go with this one. Alright, let's take it apart. There are 6 screws on this mounting plate. So if you want to take it apart, you don't necessarily have to take all the keycaps out. Now that I've taken all the screws out, now we should be able to take this out. Let's take the battery out. And here you go. This is the back of the PCB. Can you see all the electric tape that I put on? Those are the spots that I soldered all the wire jumpers. So if I peel one of that off, you can see here's already 3 of them. And there are, I don't know, more than 20 places around the board. And as I've mentioned, I snapped the PCB, as you can see here. And this is also the key that controls the LED lighting. And snapping it also breaks this key. So first things first, how do I fix the LED? Well, there's actually 2 possible reasons. The first one is that you either have a broken LED or there might be some broken connection somewhere. So first we need to understand this type of 4-leg LED, how do they work? So here's a drawing of the LED. And this type of LED chip often will have 4 legs. And there's often an indented corner. In this case, I'll draw the indented corner here for both of them. The LED chip that K6 uses has a common active pin and 3 ground pins. An active pin is just the pins that connects to the power source, and that is the pin with the plus sign that I'm drawing here, and I'll also draw the 3 ground. Some LED may have a common cathode, that is a common ground. So in this example, we'll just talk about the common active pin scenario. Now what color will the LED show is purely determined on what has been connected. For example, if these 2 pins are connected and then the LED shows green, and then we can label this as green. And then if these 2 pins are connected and then the LED shows blue, we can then label this as blue. And that's how you figure out the LED configuration and knows which LED you should get to replace your broken one. Now in our Keychron K6, the LED we use has the configuration as the follow, with the active pin being the bottom right and the blue one being the top right, the red one being the top left, and the green one being the bottom left. But if you're using other PCB board which has the LED, remember it may not be this configuration. Now let's move on to how should we test this. We can first find out the pin configuration. How do we find it out? Well, we can test it out on a working LED with a power source and try out each different pins and see what color shines. And once we find out the correct configuration, we can then check if the damaged LED is the broken one. And since we already know the configuration, we can simply just connect each of that LED legs and see if it still works. Use the same power source. Connect the positive pin with positive. In my case, I'm about to show you, I use an Arduino 5V, or you may use other power source. But remember, if you use some battery, it may not have high enough voltage for the LED. And next, I'll connect the low wire to each of the pin. And if this one works, and then I'll try the red one. And so on and so forth. And if you have tested all of them, shows the color correctly, that means you have a working LED. And if it's not shining on the board, meaning you have a broken wire somewhere. In that case, you may have to connect a jumper, which I will show you how I did it. And to test the pin for your board, I use an Arduino. Connect the active wire to 5V, and then the other one to ground. In this case, we can start testing to see which pin is which. So let's say this one, as this one looks undamaged to me, unlike the other one which is melted by my fantastic soldering skill. Let's say we start with this one. Now imagine we don't know which pin is the active pin and which one is the green and blue and so on and so forth. Let me turn off my light so that we can see the lighting in action. So let's say we start with top left. Try to see if the top left is the common active pin. So in the diagram I attach here, the red dot represents a common active and the black dot represents a ground. And in this case, nothing happens, meaning the top left may not be the active pin. Now let's try bottom left and then connect any of them. Nothing happens. Now let's try top right. Nothing happens. Now let's connect to the bottom right and then the top left as the ground. Voila. See? Some red lights comes through, meaning the top left must be the red. Now let's try top right. As you can see, some blue lights come through, meaning top right is the blue pin. Now let's try bottom left, green. There you go. In this case, you can test your LED configuration easily. Now once you have the configuration, you can then go online and purchase the right LED for you and then replace the damaged LED. Now that we have fixed our LED, it's now time to talk about how we can fix the switches. In order to fix it, we first need to talk about how switch works. So as the name implies, switch just works as a switch. So whenever we press down, electricity is allowed to flow through and complete the circuit. And that's how our keyboard knows which one got pressed. And then often switches are placed in a grid kind of connection. What I mean is that they may have the entire row of the switch connect one of their pin to the common wire, like so, and then have the entire column connect to another row, like the red one here. Let me draw another horizontal row. So often if there's just something happens in individual switch, it wouldn't affect any other one. That may be due to some poor solder joint or a broken switch. In that case, we can just put more solder on it or replace the switch and that should fix the problem. But in some cases, like in my case, due to my poor soldering technique, I actually managed to break this entire connection here. In that case, it will affect all the switch down the row and appear to me the whole row of key was broken. So let me copy one more here and connect that to this one and imagine they are sitting in the same row. Now we can test this one by just pressing it down. And in theory, if this is a working switch, it should send back some signal saying, now I'm pressed. Then we move to the next one and do the same thing. And if this one is the first switch that's not working, following switch doesn't work as well, then the problem is likely to be some broken wire within the grid near the switch. That's where the jumper will comes in and help us fix this problem. So how a jumper works, or I'd like to call it bridge as it just act like a bridge. It's like this. We can solder some wire directly from the pin to this pin and then from this pin to the adjacent pin. And in this case, we're actually telling the circuit to not worry about this dead route, which is embedded in the PCB. It's pretty hard to fix. And instead, come from here and go through to the pin and then to here, to this pin, and then to this pin. By doing so, we are actually skipping the middle broken part and give the electricity a new route to travel. And in some cases, this entire row works just fine, as you have tested each individual of this. I'll talk about how to test it later, so bear with me. But then the right pin here is broken somewhere, let's say here. How can we fix that? Well, we can also do a jumper from this pin to somewhere the adjacent component is. That one can be soldered onto the wire, which require you to scratch the surface of the PCB, or to some adjacent component. As long as it's directly connected to this pin, you can do a jumper from here to wherever. And I will talk about how to identify how the wires goes underneath the PCB. Now let's come back and take a look at the PCB. In order to test your switch, you have to have your keyboard working to some extent. If you are also fixing a K6, I would recommend to fix the key that controls the LED lighting mode first, if you also have that broken, and then switch to the mode where a pressed key will show the light. In that case, we can see which key is working and which key is not. So if you have a broken lightning key like I did, I would recommend the priority is to fix this one. And then we can simply test the others. But if you don't have the LED lighting on your keyboard, then you can go to some keyboard tester website or software. I will chuck one link that I use down to the description below. The main point is to test which key is working and which one is not. Now, how do we test it? Well, the easiest way is to press the key. But if you already have all of your switches desoldered, then you can use a metallic tweezer like this one and then just connect two of them. Let's say this one. Boom. That means this switch working just fine. But remember I said, if there is some broken one within the row of the grid, that could potentially damage all switches following it. For example, imagine we have this entire row not working from this particular switch. How can we tell if this particular switch is working? And it's the wire within the grid that breaks the connection and therefore causing this entire row of switches to disconnect. In that case, we can use one of the wire to tell. Let's assume this to connect properly. Then if I touch the left pin of the right switch and then the right pin of the left switch, guess what happens? The board should light up. Boom, there you go. Now normally, when a switch is pressed, electricity will go through this route and then to wherever the microchip is and tell the chip this key is being pressed. Now let's say this key is C and this key is V. They're adjacent to each other. What I just did, I used a wire to connect the left pin of the V to the right pin of the C. And then imagine electricity coming from the left, and then when it reaches here, electricity will be like, okay, no through row, I'll keep going. And then coming here, that's where the wire acts as a jumper or bridge. Because now the electricity can travel from this wire, which connects to the left pin of the V, all the way to the right pin of the C, and then complete the circuit. This action will actually tell your keyboard, oh, there is some electricity coming through from C, so that must be a C key has been pressed. So in that case, you can tell connection between C and V is working just fine. But imagine now we have a scenario where there is some broken connection between C and V, like so. We also have the jumper connecting between the left pin of the V to the right pin of the C. And imagine your electricity coming from the left. And guess what? Nothing will happen because it's blocked either way. And therefore, regardless of how many other switches you have, as long as they're connected to this same grid, like so, they will all be considered that because of the disconnection here. So in this case, what can we do to fix this? It's quite straightforward. Our intention is for the electricity to flow from this line to the line on the right. So let me clear all of this first. We can solder a jumper from here to here, and that will get the problem fixed. Be very careful. Do not solder the other pin, which in this case is the right pin, to the right pin. That is a no-no. Reason is that they're not supposed to be touching each other. The other pin belongs to the column of the grid, not the row of the grid. That will result in some weird behavior. And this is what the jumper will look like. And often, they will be on the same pin if they are connected in a row. Like here, the right pin to right pin, right pin to right pin. And that's only when I find out this entire row is connected in series through the right pin. And remember, if the right pin is connected horizontally in a row, that means the other one will be connected vertically to form the grid. And lastly, how can we tell if it's connected in series or not? If we look closely, we shall see some line on the PCB even if it's embedded. For K6, it's super hard to tell because it's all black. So in that case, I would recommend use some flashlight to see different reflection and in order to tell how they're connected. Remember, there is some front portion of it. Sometimes just looking at the back is not enough to tell how all the wires go. So in that case, you might need to desolder the entire board to also see the front as well. For example, this one, there is a track connecting between this pin to this component here, directly from the back. This entire metallic ring has gone, so I have to do a jumper from the pin directly to the right of this component. For example, this one, there is a very clear shape of line. Even it's embedded, it still shows that this left pin is connecting to this. Remember, only do the jumper if you can tell they're connected in series. Don't just jump from one point to another point and assuming it works. And sometimes the wire, if you're working with a K6, you can see that it stops here in like a dot. And where it goes is actually going from this back to the front. So they're connected. I know it's hard to tell, but it do takes up some patience to fix the board. Even if I use some example like this PCB from my Arduino, you can still tell how the wire goes if you look close enough and follow the track. See? And again, this dot is actually showing the wire is coming from the back to the front, somewhere. You can continue tracing where the wire goes. But well, that's it. Honestly, as you can see all the tape here, fixing this made me feel like I've just repaired an entire human heart. But I've learned so much from this. But yeah, I hope this video really helped. It took me so long to make. If you have any question, let me know down in the comment below. And if you find this video helpful, give me a thumbs up. Really appreciate it. And I hope you guys going well with your repair. But lastly, I've included some sound test for the mod I make on this K6. So please stay to the end. And thank you guys for watching. See you soon.